Section 4.7a is about recognizing arithmetic sequences. We have some definitions to look at. First, a sequence is a set of numbers in a specific order. As long as the numbers are in some sort of order, it's considered a sequence. An example of that might be something like 2, 4, 8, 16, and then I'll put dot, dot, dot to just say that it goes on forever. These numbers are in a specific order. They double. Each number doubles from the one that comes in front of it. It's a sequence. Now, a term is each number that's in that sequence. So if we were to say term number 3 is 8. So if you look up here, you say 1, 2, there's the third term. The third term is the number 8. So each one of those terms in the sequence is each individual number. We call those terms. Now, an arithmetic sequence, which is what we're actually talking about in this section, is a little different. It's a sequence where the difference between successive terms is constant. Now, what does successive mean? That means terms that are right next to each other. So you have to have terms where the difference between them is the same. That's what constant means. Let's go back up to this one up here. If I were to say, how do you get from 2 to 4? You might say something like, you would add 2. But then if I were to say, how do you get from 4 to 8? You would add 4. And how do I get from 8 to 16? You would add 8. So looking at that, the difference between each number is different. The difference between 2 and 4 is 2 because 4 minus 2 gives you that 2. 8 minus 4 gives you that 4. So if you take any term in the sequence and subtract the number that comes in front of it, you'll get the difference. Well, it turns out this term up here that I did as an example is not an arithmetic sequence. It's a sequence, it's just not arithmetic. So what would be an arithmetic sequence? Something like 1, 5, 9, 13, dot, dot, dot. Now, why is that one arithmetic? Let's take a look. How do you get from 1 to 5? Well, again, take the term and subtract the number that comes in front of it. 5 minus 1 is a positive 4. How do you get from 5 to 9? Take 9 minus 5, you get a positive 4. And how do you get from 9 to 13? Take 13 minus 9, you get a positive 4. So every term in this sequence is built by adding 4 to the previous term. Therefore, this sequence, 1, 5, 9, 13, and the next one would be 17, and so on. It's an arithmetic sequence. Now, that value there, that's called the common difference. It's the difference between the terms. So in this particular example, the common difference is a plus 4. So that's how you find arithmetic sequences. You look for sequences that have a common difference between terms, and if they do, we know it's arithmetic. Here we have a sequence, and we have to tell if it's arithmetic or not, and we're supposed to justify our answer. Well, if it's going to be an arithmetic sequence, I have to add or subtract the same number to get to each term. And for something like this, you can just look at it and tell how to go from 1 to 3. But I'm going to actually write it out so that when we get to the harder ones, they'll make more sense. To find the common difference, you take a term and subtract the one that comes in front of it. So 3 minus 1 is a positive 2. So I'll say that the difference between the 1 and the 3 is a plus 2. Now we're going to check the difference from the 3 to the 9. Again, take the 9, subtract the number that comes in front of it. You're going to get a positive 6. And then let's do one more. 9 to 27, you take the 27, subtract the 9, and you're going to get 18. So this is a plus 18. So if you look at the sequence, these numbers are different, which means the common difference is not the same. So you say, no, this is not an arithmetic sequence, and the reason is there is no common difference. Here's another sequence. We have to tell if it's arithmetic. So to get from negative 15 to negative 13. I know you can probably do that in your head, but I'm going to write them out. You take the negative 13 and subtract the number that comes behind it or in front of it. So negative 13 minus a negative is really a plus 15. So that's going to be a positive 2. So the common difference here is a plus 2. To go from negative 13 to negative 11, you take the negative 11, subtract the term that comes in front of it. Minus a negative is the same as plus. So again, you get a positive 2. Now you can see the rest of it. To go from negative 11 to negative 9, you do add 2. To go here, you add 2, and you add 2 every single time. So we can say that this is an arithmetic sequence. Yes, it is. And the common difference is a +2. So that's our justification. This example here has a lot of fractions, which is the reason why I've been subtracting these numbers all along, because when we get to this one, it's a lot harder to see what the common difference is. So how do I get from a 1/2 to a 1/4? Well, let's take 1/4 and subtract 1/2 from that. I need a common denominator if I'm going to do that, so I'm going to multiply the second fraction by 2/2. Really, that's going to be a 1/4 minus a 2/4, which is a -1/4. So my difference here is a -1/4. How do you get from 1/4 to 0? Take 0, subtract the term that comes in front of it. 0 minus 1/4 is -1/4. And then how do you get from 0 to -1/4? Well, that one you can probably think of. You subtract 1/4. And that really should be enough. You get 3 of those, you know that that's going to be the same throughout the entire sequence. So you can say that this is an arithmetic sequence, and the common difference here is -1/4. Is this sequence arithmetic? To go from 0 to 8, you're going to add 8. I figure by now you should have the pattern set. From 8 to 16, you're going to add 8. From 16 to 24, you're going to add 8. So yes, this is an arithmetic sequence with the common difference being a +8. Our last example has fractions again. It'll be a little harder. So to get from 7/8 to 5/8, what do? Well, we take 5/8 and we subtract 7/8 from that. The nice thing is they have common denominators. So 5 minus 7 is -2/8. That reduces to be -1/4. So the first difference here is a -1/4. Now to go from 5/8 to 1/8, we start with the 1/8, subtract 5/8 from that. 1 minus 5 is -4/8. That reduces to -1/2. You can stop right there, because unless these common differences are all the same, it's not going to work. Well, the first two are different, so we can say no, and the reason why is no common difference.